All right. Turn this off. All right, learning goal. Let's use tape diagrams again, equations, we're getting good at them, and reasoning to solve problems with negatives and percents. Nothing changes. We're just taking what we learned about negative numbers and what we learned about percent and throwing them into equations. Okay, so we already know negative numbers and percents pretty well. We're getting pretty good at equations, so we're just putting the two together. We're not learning anything new. Okay? So by the end of today, you can solve a story problem that has either a percent of increase or decrease in it. And you can do that by drawing tape diagrams or writing and solving an equation. So that's what we're shooting for. Any questions about the problems from the slides? No? All right, well, I have one. On the morning of the sale, the store donated 50 pairs of shoes to a homeless shelter. Then they sold 64% of their remaining inventory during the sale. If the store had 288 pairs after the donation and the sale, how many pairs of shoes did they have at the start? All right, what can you count or measure in this?
50 pairs of shoes.
What about the 50 pairs of shoes?
They were donated.
Okay. What else can we count or measure?
They sold 64% of the remaining inventory.
Sold 64% of the remaining. Okay.
They had 288 pairs after the donation sale.
Okay. What do we want to find?
The original amount of pairs they had.
So that's our X. So X is the original number of shoes, pairs of shoes. All right, so I'm going to give you a minute or two to either draw a tape diagram of this situation or write an equation. Don't solve it, I just want an equation. Remember, an equation has constants, an operation, a variable, and an equal sign. Okay, or you can draw the tape diagram. This problem should be familiar because it was one of the problems in the slide deck. DeMarc, do you have a question? No? Okay. All right, let me see what you got. Let's see what you're drawing for me. All right. Looks like we're trying the whole tape diagram thing. Good. Okay. Looks like we got an equation started. Some of you have underlined and highlighted. Like some of us are a little confused on where to start. All right, looks like somebody's trying to solve it. Do we need more time or are we stuck?
I'm stuck.
You're stuck, okay?
Stuck.
Okay, I can live with that. All right, I'm gonna start with a tape diagram and I'm gonna do it a little bit different. I'm gonna do it step by step. So I start out with X number of shoes. right? Okay, then what happens? What happens first?
They donated 50 pairs.
They donated 50. So I'm gonna take this and I'm gonna say this is minus 50. So this tape diagram is going to show X minus 50. Okay, questions on what I've done so far? Okay, now I have this much left. What do I know about that much?
That's the remaining amount. That's left.
I sold
64.
64%. Okay. What is this 288? Is that the 64% or is that what I have left?
What you have left.
What I bought.
What I have left, right? So what percent is what I have left?
48.
Oh.
46.
36.
Oh.
Okay, so that 36% is the 288.
I'm still confused.
All right, look at it and let's go through it step by step again. Okay, we start out with an X amount of shoes. Because this problem has multiple steps to it, we have to do multiple tape diagrams. We can't just do it all in one tape diagram, okay? Then we come along and we take away 50 shoes, 50 pair of shoes. So mathematically that would be X minus 50, where X is the original number of shoes. Does that make sense so far?
Yes.
Okay? Now, we're not to where we got 288 yet, because we sold, notice how this lines up here? This is what we have left right here. So 64% of this is sold, and 36% of it is left.
Oh.
So that is your 288. Now, this is 36% of what? Of X or of X minus 50? No, what is this 36% of? Isn't it of that piece right there? Well, what is this piece right here? X minus 50. So the equation is going to be 0.36 times X minus 50 in parentheses equals 288. Oh my gosh, got some big eyes there. Where the heck did all that come from? Well, let's talk through it one more time. Why do we have 0.36 and not 64? You told me 64 was, that's the part that we got left over, right? So they're not always going to give you the exact number. You may have to reason your way through it. If we sold 64%, that means we have 36% left. And this number right here, this 288, is what? That is what's left, right? So that is the 36%. Now, is it 36% of the original or 36% after I donated?
36%
After you donated. So that has to go in parentheses because we have to donate first. We have to get rid of those 50 pair of shoes before we can find 36% of what's left. Okay? Make sense?
Yes.
All right.
I need a second so I can
Yep.
screenshot.
Sure thing. Let me get out of the way.
And for this, are we going to like?
We're not going to solve it.
Oh.
I'm not too concerned about solving that one right now.
Are these the practice ones?
No, this was a activity.
Okay.
Oh.
Okay, if you want to see how it's solved, you can watch Mr. Morgan do it. Okay, he does it on the video. If you didn't do the slides, I would strongly suggest you go back and you watch Mr. Morgan do it. Even if you choose not to write everything down, just watching him do it and listening to him would be valuable. All right, because there's quite a few problems in yesterday's or this lesson's activities that are really helpful, especially when we go to take the test.
Sorry I'm late, Miss Laird. I had to step out for a minute.
That's okay, you're good. We just got finished doing the summary. We're starting on the practice problems now. All right. A backpack normally costs $25, but it is on sale for $21. What percentage is the discount? Chris, I put the link in the chat if you want to get on the Pear Deck. Okay. Whoops. Take that away. All right. Go for it. Let's see what you got for me. All right, good. I'm seeing that we are figuring out, looks like first we're figuring out how much did we save. Okay. You can use a calculator, I'm fine with that. All right, Max, you found out how much you saved. Now I want you to compare that to what? Percentage is always based off of the original. So we want to know the percentage of discount. Good, Kimberly. Good. All right, I'm seeing somebody, okay. Coop, you are right. Now I want to know what percentage is that of a discount from the original. Okay, you gave me the dollar amount, perfect. But the question is, what percentage is that? Not how much, but what percentage is that? All right, looks like I got some confused people. And then I see this. I'm seeing that. Tell me what that's finding the percentage of.
21.
Is that the discount or is that of what I paid?
That is what you paid.
That's the percent I paid. I want to know the percent I saved, right? Okay. So my top number is not going to be 21. How do I figure out how much I saved?
25 minus 21.
25 minus 21. So that's going to give me $4 that I saved divided by 25.
Which is 0.16.
Uh-huh.
And then we'll multiply that by 100.
So we saved 16%.
Percent of change.
Uh-huh, that is percent of change. Remember the formula for percent of change is?
Can you move over a little, please?
Difference over
Thank you.
original times 100.
Uh-huh, difference over original times 100. And that's what we thought about. How much did we save?
$4.
You took the difference, right? And then we're gonna compare that to the original price and then just turn that into a percentage. Okay, questions for Kimberly since she...
I need a few more seconds.
Okay, you're fine, Rachel. Okay, Rebecca, you found the percentage that you paid. I don't want the percentage you pay, I want the percentage of the discount. You can solve it that way, but you've got to remember to subtract that 84% from 100 and get, okay? There we go. Jahan, make sure you show your work, okay? All right, so Chloe tried to do, all right, Chloe, that's interesting.
It didn't work.
Let's see if it does. That's a possible way, let's see if it works. So you drew this and you said this was 25. So you know it's a discount. You know that this amount, you know this amount right here is 21. So that means this amount right here is 4. So you can use this. 4 is what percent of 25? 4 is what percent of 25? And then you'll just divide both sides by 25. You could use that.
Time to do it.
Okay, I was thinking somewhere along that. I just didn't know if it would work.
Does it make sense?
Yeah.
Yeah, you were on the right track. Because what you're finding is, what is that percentage right there? Because we know how much we paid, we know how much we saved. So you're doing the Y is what percent of X. Yeah? Different way of thinking about it. All right, anybody else? Let's see what else I got. I don't like just answers because that doesn't tell me how you thought about getting there. All right, let's go on to the next practice problem. Find each product. You can just write off to the side A, B, C, and D. Go. Most of these you should be able, all of these you should be able to do in your head. And I don't want you to use calculator. Do you cancel numerator to denominator, or do you just multiply straight across? Okay, so you end up with over what? Negative 20 over 5. Good. Now what are you going to do with that one? Tell you what, can you write that as a fraction or something? Decimal, can you write it as a fraction? And look at it and see, give you that hint. For C and D, I'm gonna give you the hint, write the decimal as a fraction. Okay, remember how to do that? The right way to say these numbers, it's not 0.6, it's what?
6/10.
6/10. Okay, write it as a fraction and then look at it. You should see something. All right. Chloe, did I lose you somewhere? Jeremiah, are you lost?
No, ma'am. I was on the phone with my mom real quick.
Oh, okay.
Sorry.
That's okay. Just wanted to make sure you weren't lost. Jeremiah, did you forget how to multiply fractions? I can go over that real quick. Everything has to be a fraction, so you have to turn negative 10 into a fraction, and you do that by putting a 1 underneath it.
I don't think I'm right for letter C.
Hmm?
I don't think I'm right for C.
You don't think you're right for C. Okay, let me find you in this. It doesn't put you in alphabetical order, which would make sense, but that's okay. Good, Rebecca. I still haven't found you. Okay, Josiah, turn that negative 10 into a fraction by putting a 1 underneath it, then multiply straight across. Okay, can you reduce negative 20 over 5, Layla? C is right. Kimberly, C is right. Mm-hmm. Okay, Jahan, how did you get 16 for B? I'm just asking, how did you get it?
It was, well, the fraction made up 1, and I know that.
Okay, if you multiply straight across, you're gonna get negative 8 times negative 3, which gives you 24, and then if you multiply straight across on the bottom, you've got 1 times 2. 1 times 2 is 2. So now you have 24 over 2. What does that reduce to? All right, so what I'm seeing is a negative 4 for A. If you got negative 20 over 5, all you did was you forgot to reduce it. Okay, for B, I'm seeing positive 12. So if you've got negative 8 over 1 times negative 3 over 2, you can multiply straight across. Or could I cancel numerator to denominator here? Yes, I can. I can make that 1, make that 4. Thank you so much. So now I've got negative 4 times negative 3, and that's going to equal positive 12. If you don't cancel numerator to denominator, you just end up with 24 over 2, and you end up taking care of the canceling right there, okay? All right, what did you notice about C? I had 10, 6, and if I write that as a fraction, what do you notice about those two fractions?
They're reciprocal.
They are reciprocals, So whenever you multiply a number by its reciprocal, you get 1. All right, what do you notice about D?
It's also reciprocals.
It is also reciprocals.
Reciprocal.
Because this one is negative 37 over 100. So when you multiply those, you also get that 1. All right, so sometimes it is better to see the fraction. Okay? All right, questions you
I
have?
need a few more seconds.
All right. All right, you good, Rachel?
I'm good.
Okay. All right. Number 3, select all that are true that show an increase by 35%. Go. X is increased by 35%.
Oh, that's what I was thinking. I thought it was asking something else.
Okay. All right, Josiah, you've got that there. Now, which ones of those expressions, A, B, C, D, E, and F, are equivalent to what you wrote out to the side? Because what you wrote out to the side is right. Okay, Jahan, so far so good. There's some more. Cooper, take a look at F and compare that to D. Are they the same? Haley, there's 2 more. Should have 4 of them. One more, Jahan. You're on a roll. Uh-huh. Good, Josiah. You can just circle them if you want, sweetie. You don't have to write them out to the side. Okay, one more, Simone. Skylar, look at what you got for D and F. Are they the same? Kylea, I want a 35% increase over X. You found me 35% of X. Do you see the difference? Chloe, look at B and compare that to A. And then look at F and compare that to A. All right, looks like just about everybody got A. Okay, A is correct. Oops, if I put it in the color that we can see.
135.
Okay, so the 100% is the 1, and then an increase of 35% is going to be the 0.35, right?
Percentages are usually not full numbers.
Okay, so A works. Does B work?
No.
B is only 35% of X. We want to increase X by 35%, not reduce it to 35%. So B doesn't work. Look at C. C has got X, and
Plus
then what are we
35.
adding to it?
35 of X.
35% of X, because 35% written as a fraction is 35 over 100. All right, look at D. If I factor this, break this up, can I do 1 plus 0.35 is 1.35?
Yes.
Okay, so is this the same as this?
Yes.
Yes. Okay, look at E. That looks weird, doesn't it? Okay, we're going to split it up. We have 100 over 100. That's 1x, right? And then we have 35 over 100. Is that 35%? So that's 135%. So E works. Now, a lot of you picked F. And I said to you, compare this to that. Or compare this to this. Do you see why it doesn't work?
Yes.
Yeah.
This
Yes.
is not in percentages. Well, it is, but this is 10,000%, and this is 3,500%. Because remember, a percent is per 100. Okay? And I don't think we're increasing it by that much. All right, questions you have? All right, let's go to the next slide. Complete each sentence with the word discount, deposit, or withdrawal. Go. Write A and then write the word, write B and then write the word. Rachel got kicked out.
I got kicked out.
I saw that. Let me give you the code to get back in.
Thank you.
You're welcome. Chloe, we'll see if your internet's more reliable than hers. I think she just got kicked. Nope, she's there. Somebody got kicked out.
Did you say my name?
I just made you a co-host, Chloe.
Oh, okay.
All right. A's are looking good.
Do we write on the slide?
Yeah, you can type on the slide.
Oh, I didn't realize that there was a way to type. My bad.
It's okay. We're all learning. It's not very often I give you a typed one. Max, are you confused? Off to the side there, you should be able to type in the box. Okay.
I do not.
Oh, okay. That's fine. I just didn't want to leave you out if you were confused. All right. Looks like we got A is withdraw, B is a discount, C is a deposit, and D is a discount. D is a discount because we're saving money. Okay? Questions on any of those vocab words? All right, onward to the next one. Well, come on, computer. All right, here are two stories. Let's look at the first one. The initial freshman class at a college is 10% smaller than last year's class. But then during the first week of classes, 20 more students enroll. There are then 830 students in the freshman class. What can we countermeasure? What's the story about? Let's start there. What's the story about?
College students.
College students, okay? What can we countermeasure?
10% smaller.
10% smaller than last year, okay?
More students.
20 more students show up after the first week,
There are 830 students in the freshman.
okay?
Were you able to write on this slide?
No, I left it, I didn't make the slide a right slide. All right. What is X in this case? What is our unknown?
How many were in
The original
Yeah.
class. Because this 10% is off of last year, right? Okay. So if I look at this, it's 10% smaller than last year. So that means this year it is 90% of X, okay? And we would write that as 0.9X, right? And then what happened to that 90% of X? What happened? We added 20 more students. So wouldn't that be 0.9X plus 20? What do you think? And then this whole thing right here is going to equal 830 students. What do you think of that thought process? Make sense? Okay.
Yes.
So that would be equation 1, right?
Yes.
All right. Read story 2 to yourself. What is this story about?
A store and a computer.
Selling a computer, right? What can we countermeasure?
$20.
$20. And that's a
10% off.
reduction. Okay, what else?
10% off.
10%
The
off.
10% discount.
Okay, and
The customer pays
The
830.
customer that pays
All right.
$830.
so what is our X? What is our X?
How much the original?
The original cost of the computer. And then what do they do with it?
They subtract.
They took off 20%.
They took off $20, right? So now we're here. So this would be X minus 20, right? Now we're taking this and doing what with it? Subtracting what?
10%.
10%. So that leaves us 90%. So would this be 0.9? Now why do I have the parenthesis there?
Because you have to first subtract the $20.
Yes. Okay?
Okay.
That forces us to do the $20 first. Anybody see it different of why we have to do the parentheses in that one? I liked your explanation, okay? So that's B, or story 2. All right, now guess what you get to do?
Oh, solve each equation.
Yep, next slide. Solve it. Any subtraction, I'll walk you through the steps. Any subtraction,
No.
any parentheses.
No.
Are all the variable terms on one side and the constant terms on the other side?
No.
Okay, make it so. As Jean-Luc would say. Make it so. Jeremiah, try it without the tape diagram. Try it with the numbers.
I could do the first step, but I'm stuck on the last step.
Let me find you again. Okay, so what's attached to the x?
0.9.
How are they connected to each other?
Multiplication.
How do I undo it?
Division.
So I'm going to divide both sides by 0.9. Don't let it freak you out because it's not a whole number. All right, what if I drew a tape diagram, a hanger diagram of this? Some of you look a little confused, so it's not going to work exactly, but it'll be okay. Kind of a visual. What do we want to get rid of?
20.
The 20, we want that hanging by itself before we can divide, right? Okay, so we have to subtract 20 here and subtract 20 here. So that's the same step we're going to take up here. All right. Okay, Jahan, you've got it down to 0.9 x equals 810. Now you have to solve for one positive variable. How would you do that? What's connected to the x? How is it connected and how will we undo it? Good, Haley. Okay, it looks like some of us don't even know where to start. Good. Kimberly, tell me what that 900 means. 900 what?
$900.
Whoops, Layla, you lost your X there next to your 0.9. Perfect, Skylar, just tell me what that 900 means. All right, I got some really good answers here. Good. Rachel, it looks good. All right, let's go through it real quick. So I saw, let's see, Rebecca subtracted 20. Rebecca, why did you subtract 20 first?
Because they added 20.
Okay, so what were you trying to do when you subtracted that 20? Algebraically, what were you trying to do to the equation? Were you trying to get the variables on one side and the constants on the other side? Okay, all right, then I saw, let's see, Rachel, I saw that you divided both sides by 0.9. Can you tell me why you did that?
I divided them both by 0.9 because I was trying to get x by itself, and x was connected to 0.9 by multiplication.
Very good. All right. Then we got 900. What does that 900 represent? Oh, $900? This problem was about what?
College students.
College students.
Oh, I was thinking of the other.
Okay, so this is 900 students last year in the freshman class. Okay? Some good work there. Some of you are getting very good at showing me your steps. Okay? The rest of you, you're going to get there. You're showing me more than you were showing me at the beginning of the week. Okay? Any questions you have for me? Or Rebecca or Rachel? All I did was copied what they wrote. Okay, who needs more time? All right. Let's go to the next one. Is there subtraction?
Yes.
Yes.
Okay, get rid of it first. Copy, change, opposite. Then you're going to ask yourself, are there parentheses? If there are, you have two options to get rid of them. Divide or distribute. Haley, don't forget that when you do change it to addition, you've got to take the opposite of 20. Just put a negative sign up above it. There you go, and put your parenthesis back in there. Yeah, could. Yeah. There you go. Okay, now you want to get rid of parentheses. All right, Jahan, now you want to get rid of parentheses. Oh, Kimberly, you lost a negative sign.
Oh,
Is that x minus 20 or x plus negative 20? This is why I want you to get rid of the sign. Because when you multiply 9/10 times 20, you've got 18. But you put plus 18. It needs to be minus 18. Or do copy, change, opposite, and then it'll be negative 18. Does that make sense?
mm-hmm.
Okay.
I forgot to do the
That's why I want you to do copy, change, opposite, because you will forget that this sign goes to the 20. And subtraction is the same thing as the opposite. Okay, Skylar, now you got to get one positive variable. You're good to there. It's money. Isn't it money? Wasn't it a computer?
Yeah.
Okay. Good, Rachel, you're on the right track. Okay, Layla, now what's your next step? Get rid of parentheses. Here are your two options. Okay? You're on the right track.
Miss Lawyer,
Yeah.
wouldn't my new equation be 0.9x plus negative 18?
All right, so you've got negative 18. How do I make negative 18 to move? I'm going to put positive 18 with it. Okay, and if you go back and think about it, I was subtracting 20 here, which becomes 18 because you distributed. So how do I undo subtracting 18? I add 18 to both sides.
So I'm adding 18 to this. Okay.
And a negative 18 and putting a positive 18 with it is the same thing as adding 18. There you go. Awesome job, Skylar. Great work. Good, Rachel. Layla, you were on the right track. 0.9x, you had that right. plus, because you see a plus sign there. Keep your X there, Now put plus. Now take your calculator and multiply 0.9 times negative 20. You're doing it exactly right. Kylea, there you go. Plus negative 20, equals 830. Now put the parentheses back in there because you haven't taken care of them yet. You just got rid of subtraction, All right, Jeremiah, now you need to get rid of the parentheses. You can either divide or distribute. All right, Josiah, I'm not sure what you did. Can you explain to me what you did? All right, this is money, Jasmine, so you can't leave it as 4/9. This one was the price of a computer. All right, I want to give you some time, so we're going to go over this. Max and Coop, are you stuck? Oh, you do yours on paper. Are you doing yours on paper too? Okay. Okay. All right, so let's work it together. So our first step is to get rid of subtraction. The reason I have you do that is so you don't lose this sign right here when you distribute or divide, okay? Now it looks like most of you distributed, which is fine. You can do it either way. And it looks like most of you did this. So you got 0.9x plus negative 18 equals 830. I'll do it the other way in a minute. I see, Chloe, you're trying division first. Go ahead and keep going on that.
I was trying something, but
Go ahead.
I forgot what I was supposed to put. So I got to here, x plus negative 20 equals to 900, but then
No,
I didn't
that's
know.
9. Is that 900? 830 divided by 0.9? I don't think so. Take your calculator and see it again. Do 830 divided by 0.9. I'll come back to you in a minute. Then I saw that you people, some of you put plus 18. So it looks like you were trying to get the variable isolated, the variable term. And you got 848, and then you realized you needed one of these, so you divided both sides by 0.9, not x, just 0.9, and that gave you x equals 422.22, no, 942. And then it was the price of the computer, so it's dollars. Okay? Questions you have about that method? All right, let's try it with Chloe's method.
She's gonna call me out here.
Yes, I am. I'm sorry. You're the one. Oh, you're the only one that did it this way, and it works this way.
Division?
Did you do division first, Jahan? Okay.
What was the answer again?
$942.22.
Okay, thank you. I just want to make sure that I was correct.
No problem.
How many problems are there?
We're almost done. So you're going to divide both sides by 0.9. You get x plus negative 20 equals
922 and then 0.2, and then it keeps repeating.
and it's money, so I'm gonna do 22 cents. Then I'm gonna add 20 on both sides. So that gives me the cost is $942.22. Okay, this one works because it's money and you can divide and you know money goes to the hundredths place. Okay? Either way works. I'm fine with that. How do we feel about that? Saw some good work, a lot better than the first one. Yes, I think we're getting this. Okay, next slide. In 1 minute, write the most important thing that you got out of today's lesson. Go.